There is a little nuance here in the color coding that I want to explain because you might have seen it on one of the homework assignments, but I want to make sure that you understood what was happening there so that you can do it on your own. So here's a brief review of color coding, and I'm going to look at two different circuits. And the first one is a series circuit with 4 round light bulbs. And before we can color code, we have to think about the flow rate, the resistances, and the pressure differences because the color coding is a visual representation of the pressures in the different wires. So to think about flow rate, I first realized that I have a series circuit, and from our observations in the lab, we know that the flow rate is the same in every wire in a series circuit. So flow rate is the same everywhere. Resistances are all the same because these are all exactly the same type of light bulb. And now we're ready to think about pressure differences. So the pressure difference is what drives the charge through the light bulb. So it's the pressure differences that are creating the flow rate. And the resistance is a factor in that. So we have the same resistance everywhere, but we also have the same flow rate everywhere. So because the flow rates are the same and the resistances are the same, we can conclude that there must be the same amount of push through each of these. If you had a different amount of push through two objects that had the same resistance, then you would have different flow rates. But if you have the same push through objects with the same resistance, then you get the same flow rate. So since we have the same flow rate and the resistance are the same, we can work backwards and conclude that the pressure difference across the first light bulb must be the same as the pressure difference across this one and this one and this one. So as a result, we know that we have 4 pressure differences that are all equal. So we know this wire is at highest pressure, which is represented by red, and we know this wire is represented by blue, that's the lowest pressure. And then somehow we have to get from red to blue with 4 equal drops. So it's going to drop from red to something here, then from something there to something here, from something here to something here, and then from here to here. And all those drops have to be equal. So by looking at the colors, because we have 5 colors, we can see that we have 4 equal drops if we use those. So red to orange is the same amount of drop as orange to yellow, which is the same amount of drop as yellow to green, which is the same amount of drop as green to blue. And since sometimes it's easier to comprehend these things when you have some numbers, let's just suppose that the high pressure is represented by the number 12, that's a pressure of 12, and the low, the blue, is represented by a pressure of 0. Then if we were to think about what kind of pressure values could represent these different colors, orange could be 9, yellow could be 6, green could be 3. And you'll see that then as you go from red to orange, there's a pressure difference of 3, right? Going from a pressure of 12 to a pressure of 9, the difference is 3. And then the difference from orange to yellow is 3. And the difference from yellow to green is 3. And the difference from green to blue is also 3. So you have equal pressure differences represented by using these colors. Now what if you have a circuit that has only 3 light bulbs? Well, once again, the flow rate's the same everywhere because it's a series circuit. The resistances are all equal because the light bulbs are all the same. So from that, we can conclude that there must have been the same push through each light bulb. So we have to have equal pressure differences. Well, that means we need to have 3 equal pressure differences. One here, and one here. Looking at our colors, if we use red, orange, yellow, and green, that gives us 3 equal pressure differences, but it doesn't get us from high pressure to low pressure, which is what we have to have. This wire has to be red, and this wire has to be blue. So you can see here with these little pencil lines that I can divide this into 3 equal, gaps. If I go from red to kind of in between orange and yellow, and then from there to in between green and yellow, and from there to blue, I have 3 equal pressure differences. And even thinking about numbers might help, right? To get from 12 to 0 with 3 equal jumps, I could drop by 4 each time. I could go from 12 to 8, 8 to 4, and 4 to 0, which is really what's going on here. But how do you represent that with the 5 colors that we're using? You could, get more pencils out of different shades, but we're not going to do that. We're just going to use these 5 colors. What we do is we say, well, 8 is in between these two. The pressure difference has to be sort of in between. So what you do is you just use both colors. You outline it with orange and outline it with yellow, and that means that you're talking about a pressure difference that is between orange and yellow. And same thing here, to represent this one, the 4, you could represent that with yellow and green, which means it's a pressure that is between the yellow pressure and the green pressure. Okay, so hopefully that helps you understand one of those questions on the homework, and understand how to color code when you need to represent a pressure value that is between something else.